Hi, it's Mrs. Pope, and today we're going to talk about rational exponents. Our goal is to write and simplify expressions in rational and radical forms. Rational is where we have an exponent that's a ratio or a fraction, and radical is when we actually have the radical in the form. So here's a key concept. For any real non-zero number b, and any integers x and y, where y is greater than 1, b to the x over y, so that's a rational exponent, can be written in radical form by writing it as the y root of b to the power of x. Now let's look at it with numbers. So if you have 27 to the 1/3, this can be written as the cube root of 27 to the power of 1. So my denominator becomes the root that we're taking, the index, and then the numerator becomes what we raise it to the power of. So 216 to the 2/3 power, that would turn into the cube root of 216, and we would raise that to the second power. And now these are easy to figure out. The cube root of 27, well, that's just 3. The cube root of 27 is 3, and then 3 to the first power is just 3. And then the cube root of 216 is going to be 6. So 6 squared is going to be 36. All right. So example 1, we want to simplify. I want you to write these in radical form over here, and then write them in exponential form over here. So it should move pretty quickly. X to the 1/6, well, of course, that's the 6th root of x to the first power. A to the 1/5, 5th root of a to the first power. D to the 7/4, 4th root of d to the 7th power. And now let's go the other way. If you have it in radical form and you want to put it in rational form, we need to take this and make it have an exponent that is a fraction. So the 4th root of z is really z to the 1/4 power. 8th root of c is really c to the 1/8 power. Now look here, we have the cube root of x to the -5. So what do you think that's going to be? So we have x, and remember, just don't let the negative throw you off. Just like we have our 8 here, this is going to be our denominator, and this is going to be our numerator. So x to the -5/3. So that really turns back into the cube root of x to the -5. I understand that it's under the radical. That's still okay. It'll still be the exact same way as if you would put it on the outside of the parentheses. If you don't believe me, try it out. Put a number in for x. Even if you do believe me, try it out. All right. Example 2. Now let's use this and actually evaluate some functions. So 256 to the power of 3/8. So another way to look at that is the 8th root of 256 cubed. So the 8th root of 256, if you use your calculator, you would find out that that's 2. And if you cube 2, you end up with 8. All right, how about 81 to the -1/4? Reminder, we haven't done this in a while. Negative exponents go to the denominator. So if you have a negative exponent here, we're going to change that and put it into the denominator to take care of it. So this turns into 1/81 to the 1/4. That's how we take care of the negative exponent. And now this is going to be 1/4th root of 81 to the first power. And the 4th root of 81 is 3. 3 to the first power is 3. So our final answer is just 1/3. All right, let's look at this one. Negative 3,125 to the power of -1/5. Let's first change it to 1/-3,125 to the 1/5 power. Don't change the negative of the number. The negative only gets changed on the exponent by putting it in the denominator. So that really means 1 over the fifth root of negative 3125 to the first power. And the fifth root, using your calculator, of negative 3,125 is 5. So our final answer will be 1 over negative 5, or negative 1/5. Let's look at a real-world example real quick. Did you know that milk did not always cost $2.99? There's something that we have in our economy that's called inflation, and it means that the price of things go up year after year. So here's a formula to help you figure out the future cost of an item due to inflation. So yeah, like when your parents or grandparents were growing up, milk was not $2.99. So it's probably like a quarter. Well, that might be great-grandparents. But anyway, so the future cost of an item, the current cost, is 1 plus the rate of inflation to the power of n, however many years it is. So if milk costs $2.99 today, how much will it cost in 9 months? Well, we should expect that based on inflation, it should be more if the annual inflation rate is 5.3%. Well, let's use our formula and see how we can have a rational exponent that actually comes into play in the real world. So the future cost of the item is equal to the current cost, which is $2.99, times 1 plus the rate, which is 0.053, because I turned it into a decimal, move it 2 to the left, to the power of years. Well, I don't know how many years. I'm not looking for years. I'm looking for months. So 9 months out of 12 months is how many years? It's 9/12 of a year. Of course, we could simplify that, but I like to see it that way so we can see it's 9 out of 12 months. So if we simplify this, you'll end up with your cost being about $3.11, which is an increase of 12 cents. So this is our annual inflation, and the increase would be 12 cents over in the 9 months. So your milk would be about 12 cents more than it is today. Thanks for watching, and remember, you are responsible for your own learning.